the man who mapped the infinite edges of our universe, is buried somewhere on this earth, and absolutely no one knows where. It is truly one of the strangest historical vanishings ever recorded. We are looking at a brilliant mind that demanded absolute empirical precision from the stars, yet actively fabricated almost every single detail of his own public persona. He was an Oxford-educated aristocrat who was actually a small-town Missouri boy with a fake accent. And perhaps the wildest, most tragic irony of all, he actually refused to believe his own greatest discovery. Welcome to Legendary Lives Unveiled, where we peel back the carefully crafted theatrical masks of history's icons to reveal the deeply conflicted humans underneath. If you are fascinated by the hidden tragedies and untold mysteries of the greatest minds, be sure to subscribe, like, and share this journey into the dark with someone who loves a deeply complex mystery. Today, we have a towering stack of historical records, from his wife Grace's personal diaries to incredibly detailed astronomical observation logs, all pointing to the monumental life of Edwin Powell Hubble. You hear the name Hubble, and you likely picture a brilliant, stereotypical scientist in a lab coat, forever immortalized by the famous space telescope. But you must rethink everything you thought you knew. The man himself was a boxing, basketball coaching, high-jumping prodigy who also struggled with severe dyslexia. Born in 1889 in Missouri, Edwin Powell Hubble was not your standard indoor bookish intellectual. His physical capabilities were overwhelming. His family moved to Wheaton, Illinois, just outside Chicago, before his first birthday, and as he matured, he developed a towering, powerful build. Standing a robust 6'2" in an era when the average male height was significantly lower, he was a giant. In 1906, at a single high school track and field meet, he won 7 first-place events and 1 third-place event. 7 in one day. He even set the Illinois state record for the high jump. Going on to the University of Chicago, he led their basketball team to their first Big Ten conference title in 1907 and sparred as an amateur heavyweight boxer against professional-level fighters. Yet, alongside this intense, almost violent physicality, you have a kid devouring Jules Verne novels, specifically 20,000 Leagues Under the Sea, and staying up all night to stare at the sky. But his academic records show he was an absolutely atrocious speller. While his grades were universally excellent in complex subjects like mathematics, physics, astronomy, Latin, and Greek, his spelling was famously terrible throughout his entire life. Early 20th century academia viewed this as a bizarre failing or a lack of discipline, but modern biographers, analyzing his handwritten letters and observatory logs, strongly suspect he had a form of dyslexia. We now understand that dyslexia is highly correlated with gifted spatial thinkers, individuals who possess an extraordinary ability to visualize complex three-dimensional structures in their minds. He couldn't arrange the letters linearly on a flat page, but he could arrange galaxies in a three-dimensional void in his head. It was a cognitive trait that would become absolutely vital for someone trying to map the geometry of the entire universe. This hulking athlete was trying to figure out his place in the world, caught in a massive tug-of-war between 2 father figures. On one side, his grandfather, Dr. William James, actively nurtured his cosmic curiosity, literally building Edwin a homemade telescope for his 8th birthday. That instrument provided a tangible, physical connection to the night sky. Young Edwin once stayed up all night with a friend to watch a total lunar eclipse, practically paralyzed by the fear that he might miss a single transient moment of the shadow moving across the lunar surface. Dr. William James and Edwin's mother, Virginia, provided the intellectual freedom he craved. Diametrically opposed to this warm environment was his father, John Powell Hubble. John was the archetype of a strict, puritanical Victorian disciplinarian. an insurance executive who traveled constantly, living out of hotels across the Midwest. John had harbored failed ambitions of becoming a lawyer himself. He projected that exact ambition directly onto his son, absolutely forbidding Edwin from pursuing a career in astronomy because he dismissed it as an impractical, financially ruinous waste of time. He issued a strict mandate. His son must study law. Edwin likely built his invincible armor of physical achievement to win the approval of this absent, overbearing father, hiding his true nerdy passions. He would knock out boxers in a ring, then go home to quietly escape by gazing through a homemade telescope in the dark. He learned very early how to splinter his identity, flawlessly executing the role of the rugged Midwestern athlete and dutiful pre-law student to appease his father's utilitarian worldview, while his internal life was completely consumed by the cosmos. The tragic culmination of this dynamic happened in the winter of 1913. John Powell Hubble's health failed, and he died at the age of 52. Edwin, being the dutiful son, made a solemn deathbed vow to his dying father that he would abandon his dreams of science and dedicate his life to the law. The timing altered the trajectory of Hubble's life entirely. Just prior to his father's death, Edwin had been awarded a Rhodes Scholarship to Oxford University. Burdened by immense, suffocating grief and this inescapable promise, he traveled to England. He honored the letter of the law, studying Roman and English law to earn his degree in jurisprudence. But he exploited the loopholes. He began studying literature and Spanish, and crucially, he fundamentally rewrote his entire identity. The reinvention was total. This Midwestern country boy, with a Missouri twang, quickly realized that the British class system and the aristocracy of academia required a very specific kind of theater. He adopted an accent that his own American colleagues later mocked as incredibly phony. He went full cosplay, wearing heavy tweed jackets, +4s, carrying a walking cane, and smoking a pipe. He completely discarded his roots to become a walking caricature of a British aristocrat, internalizing the affectation so deeply that he began referring to things as topping and jolly. When he finally returned to the United States, carrying a law degree he despised, he refused to break character from this entirely fabricated persona. Moving to Louisville, Kentucky, where his widowed mother and siblings had relocated, he briefly practiced law to support them. Imagine the sheer absurdity. A towering heavyweight boxer, dressed in British hunting gear, carrying a military cane, speaking with a fake upper-crust aristocratic accent, teaching high school Spanish and physics, and coaching the boys' basketball team in rural Kentucky and across the river in New Albany, Indiana. Yet beneath the tweeds, his genuine charisma shone through. The senior class of 1914 even dedicated their yearbook to him, praising him as a loyal friend and an inspiring presence. But the law practice was suffocating. The call of the stars was far too strong. He eventually wrote to his old astronomy professor at the University of Chicago, Forrest Ray Moulton, essentially begging for a way back into science. It worked. He secured a position at the Yerkes Observatory in Wisconsin and finally began his PhD in astronomy. Why maintain the fake British accent? The early 20th century scientific establishment was incredibly rigid. A boys' club dominated by wealthy, privately educated East Coast or European men who considered science a gentleman's pursuit. Coming from a middle-class background and entering the field late, Hubble used the Oxford persona as an intellectual shield. It gave him an immediate, unearned aura of sophistication and lineage. This manufactured mythos was amplified by his brief military career. In 1917, just as he was finishing his PhD dissertation on faint nebulae at Yerkes, the U.S. entered World War I. He received a dream offer from George Ellery Hale to join the prestigious Mount Wilson Observatory in California. Instead, Hubble stayed up all night to finish his thesis, defended it the next morning, sent a telegram to Hale saying, "Regret cannot accept your invitation. I'm off to the war," and immediately enlisted in the infantry. Assigned to the 86th Division, the Black Hawk Division, his natural leadership and imposing physical presence saw him rise quickly to the rank of major. He shipped out to France in September 1918. But here is the critical, often omitted historical detail. The armistice was signed before his division ever reached the front lines. He never saw a single day of combat. Yet he returned from Europe, and for the rest of his life, insisted others address him as Major Hubble, wearing military boots to the observatory, keeping the cane and keeping the accent. In the summer of 1919, Major Hubble finally arrived at the Mount Wilson Observatory in Pasadena, California, showing up on his first day still wearing his military officer's uniform. Mount Wilson was the undisputed epicenter of observational astronomy, housing the newly completed 100-inch Hooker telescope, an engineering marvel and the largest telescope on the planet. And who did this Oxford-educated fake British major end up partnering with to map the universe? Milton Humason. Humason was a total contrast. He had dropped out of school in the 8th grade because he just loved the mountains. When the observatory was first being built, he got a job as a mule skinner, driving the teams of animals, pulling massive wagons, and hauling delicate, multi-ton telescope parts up a treacherous, unpaved mountain trail. After leaving to work on a ranch, the mountain drew him back, and in 1917, he took a job simply as a janitor at the observatory. From sweeping floors, he became a night assistant. The astronomers realized this 8th grade dropout had a magical touch with these massive, delicate instruments. Observational astronomy in the early 20th century was a grueling trial of physical endurance. The 100-inch Hooker telescope was a massive, multi-ton structure of steel and glass, housed inside an enormous dome that could not be heated, because any heat would cause air ripples and ruin the incoming starlight. In the dead of winter, it was literally freezing. Astronomers wore heavy aviation suits, like pilots in open cockpits, just to survive the night. To capture the extremely faint light of a distant nebula, a single photographic glass plate had to be exposed to the sky for hours, sometimes spanning multiple nights, for a total exposure time reaching 40 hours. Because the Earth is constantly rotating, the telescope had complex clockwork gears to keep it pointed at the exact same spot. But temperature changes caused the metal to expand or contract. Shifting weight caused tiny flexures, and atmospheric refraction constantly changed. If the telescope drifted by a fraction of a millimeter, days of work were ruined. So, Humason had to sit perched on a tiny platform, high up in the freezing, pitch-black dome. His eye was aligned with illuminated crosshairs. For hours on end, without blinking, without shivering, he made continuous microscopic manual adjustments using hand controls to keep a guide star perfectly pinned to the crosshairs. If his hand cramped, a 40-hour exposure was destroyed. Humason became the undisputed master of this, possessing the mechanical intuition to anticipate exactly how the massive metal structure would behave. Recognizing this genius, Observatory Director George Ellery Hale promoted the 8th grade dropout janitor to the scientific staff alongside PhD astrophysicists. When Major Hubble wanted to study the absolute faintest, most distant objects in the night sky, he fundamentally lacked the physical finesse to operate the Hooker telescope at its absolute limits. Humason became the interface between Hubble's mind and the universe. Together, this bizarre, odd couple, the fake aristocrat and the genius mule driver, were about to look at a tiny smudge of light in the night sky and accidentally destroy the entire known universe. To understand the magnitude of what they did, we must first look at what humanity actually believed the universe was in the early 1920s. The astronomical community was fiercely divided by what became known as the Great Debate. The dominant view was championed by Harlow Shapley, a brilliant scientist who had worked at Mount Wilson before becoming the director of the Harvard College Observatory. Shapley argued forcefully that the Milky Way galaxy, our galaxy, was incredibly massive, perhaps 300,000 light-years across. But crucially, he believed the Milky Way constituted the entirety of the universe. If you stepped outside and looked up, every star, every weird cloudy patch was local. The Milky Way was the absolute boundary of existence. Those cloudy patches in the sky were called spiral nebulae. Shapley and his supporters believed these nebulae were simply clouds of gas and dust, perhaps solar systems in the process of formation, located safely within the boundaries of the Milky Way. Just local weather. However, a competing faction of astronomers believed these spiral nebulae were actually island universes, entirely separate, independent galaxies just like our own, located incredibly far away across an unimaginably vast void. But the debate was deadlocked. No one had a telescope powerful enough or a measuring tool accurate enough to definitively prove the physical distance to these nebulae. Enter the 100-inch Hooker telescope, Edwin Hubble, and crucially, the brilliant foundational work of a female astronomer named Henrietta Swan Leavitt. Without Leavitt's mathematics, Hubble would have simply been staring at blurry photographs. Working at the Harvard College Observatory a decade earlier, her painstaking job was to analyze thousands of photographic plates to catalog the brightness of stars. She began focusing on a specific class of stars known as Cepheid variables. Unlike our sun, which burns at a steady brightness, Cepheid variables physically pulsate. They expand and contract, getting brighter and dimmer in a highly regular, predictable cycle over a period of days or weeks. Through meticulous analysis of Cepheids located in the Magellanic Clouds, Leavitt discovered a profound, direct mathematical relationship between the length of a Cepheid's pulse, its period, and its true, intrinsic, absolute brightness, its luminosity. She realized that the longer a Cepheid takes to pulse, the inherently brighter the star actually is. Imagine standing in a huge dark field, seeing a light in the distance. You have absolutely no idea if it is a small, weak flashlight 10 feet away or a massive stadium floodlight a mile away, because both might look equally bright to your eye. But if you know for an absolute fact that you are looking at a standard 100-watt light bulb, you can calculate exactly how far away it is, simply by measuring how dim it appears. The dimmer it looks, the further away it must be. Leavitt essentially figured out how to read the wattage of these pulsating stars. By timing their pulse, she knew their inherent brightness, and comparing that to how dim they appeared on Earth, she could calculate the exact distance. They became the ultimate standard candles of the cosmos. Applying Leavitt's standard candles, we fast forward to the night of October 5th, 1923. Hubble is at Mount Wilson, using the 100-inch telescope to painstakingly photograph the Andromeda Nebula. With Milton Humason working the gears, he takes a long exposure. Down in the dark room, developing the glass plate under a magnifier, Hubble spots a tiny speck of light. He initially categorizes it as a nova, a star that has suddenly exploded and briefly flared in brightness. But Hubble was meticulous. He went back and compared this new plate to dozens of older plates of Andromeda taken by other astronomers. He realized this speck wasn't a one-time explosion. It was pulsating. It was getting brighter, then dimmer, then brighter again in a regular cycle. He took his pen, violently crossed out the N he had written for nova on the glass plate, and wrote var in stark red ink. Variable. He had found a Cepheid variable star located entirely inside the Andromeda Nebula. You can literally look at that glass plate today in a museum and see the exact moment human understanding of the universe fractured. Because once he found that Sheffied, he applied Leavitt's math. The number that came out of that equation was incomprehensible. It fundamentally dismantled the Shapley model. The math showed that this star, and therefore the Andromeda Nebula itself, was not thousands of light years away on the edge of the Milky Way. It was nearly 1,000,000 light years away. It was undeniably outside our galaxy. Andromeda was an island universe of its own, containing billions of its own stars, separated from us by a terrifying expanse of empty space. Imagine the philosophical terror and awe of that moment in the freezing observatory. Suddenly, everything humanity has ever known, the entire Milky Way, is instantly reduced to a single speck of dust in an ocean of billions of other specks. The cosmic real estate was multiplied by infinity overnight. When Hubble finalized his findings, he sent a letter to Harlow Shapley. Reading the letter in his office at Harvard, Shapley reportedly handed it to a colleague and said, "Here is the letter that has destroyed my universe." It was arguably the most significant paradigm shift since Copernicus moved the Earth from the center of the solar system. Hubble formally published these findings in 1924, and the New York Times ran a feature headline declaring that Hubble had found island universes. But the real shock was what that massive universe was actually doing. To understand this next leap, we must rewind slightly to the pioneering work of Vesto Slipher. More than a decade before Hubble's breakthrough, Slipher, working at the Lowell Observatory in Flagstaff, Arizona, was attaching intricate devices called spectrographs to the back of his telescopes. A spectrograph functions like a highly sophisticated prism. It breaks the incoming white starlight down into its component colors, creating a rainbow spectrum. Because stars are made of specific chemical elements like hydrogen or helium, those elements absorb precise wavelengths of light, creating dark, vertical lines across the spectrum, like a unique chemical barcode for the galaxy. Slipher noticed a deeply weird anomaly. The barcodes were in the wrong place. The entire specific pattern of absorption lines was shifted all the way toward the red end of the visual spectrum. In physics, this phenomenon is perfectly explained by the Doppler effect. If an ambulance is driving aggressively toward you, the sound waves are compressed, making the siren incredibly high-pitched. The exact millisecond it passes and speeds away, the sound waves stretch out and the pitch drops to a deeper wail. The exact same physical principle applies to light waves. If a massive galaxy is moving toward us, its light waves are compressed, shifting toward the higher frequency blue end. But if the galaxy is speeding away, the light waves stretch, shifting the entire spectrum toward the lower frequency red end. Slipher looked through his spectrograph and saw that almost everything in the sky was red. Everything was rushing away from us at incredibly high speeds. Slipher had the velocity data, but he lacked the distance data. In the late 1920s, Hubble and Humason joined forces. Humason pushed the telescope to its absolute mechanical limits, gathering incredibly difficult redshift data from faint, distant galaxies. Hubble took that velocity data and plotted it on a graph against his calculated distances. What emerged was an undeniable linear relationship, published in 1929 and known to history as Hubble's law. The further away a galaxy is from us, the faster it is receding. This implied that galaxies aren't just flying through an empty room of static space. Space itself, the actual fabric of the void, is expanding, exactly like dots drawn on the surface of an inflating balloon. This completely flipped theoretical physics on its head. Up until this moment, the brightest minds on Earth, including Albert Einstein, had firmly assumed the universe was static, eternal, and unchanging. In 1917, Einstein formulated his equations of general relativity. But the math of gravity presented a problem. Mutual gravity should cause a static universe to collapse. Einstein was so philosophically wedded to a static universe that he introduced a fake mathematical variable into his own pristine equations, a fudge factor he called the cosmological constant, just to provide an arbitrary anti-gravity force to keep the universe perfectly still. When Hubble published his empirical data in 1929 showing undeniable observational proof that the universe was expanding, Einstein realized the magnitude of his theoretical error. In 1931, Einstein traveled to Pasadena, visited the Mount Wilson Observatory, met with Hubble, and publicly renounced the cosmological constant, famously referring to it as the greatest blunder of his life. But here is where we hit the conspiracy. Hubble gets all the credit, but the historical sources reveal a massive mystery regarding a relatively obscure Belgian Catholic priest named Georges Lemaitre. Lemaitre was a brilliant, highly trained theoretical physicist. In 1927, 2 full years before Hubble published his famous graph, Lemaitre published a theoretical paper in a Belgian scientific journal called the Annals of the Scientific Society of Brussels. In that paper, Lemaitre independently used Einstein's equations of relativity, combined them with Slipher's early redshift data and Hubble's early preliminary distance estimates, and derived the exact same linear relationship. He explicitly theorized the expanding universe and mathematically calculated the rate of that expansion before Hubble proved it observationally. But no one read the obscure Belgian journal. It wasn't until 1931 that the Royal Astronomical Society in London recognized the profound importance of Lemaitre's paper and decided to publish an English translation. Yet, when the translation was printed in the monthly notices of the Royal Astronomical Society, the specific and highly mathematical paragraph where Lemaitre calculated the rate of expansion, the exact paragraph that definitively proved he got to the answer before Hubble, was completely deleted from the text. Decades of intense rumors ignited. Did Hubble orchestrate a cover-up to steal the ultimate cosmological crown from a Catholic priest? This suspicion cast a long shadow over his legacy, until 2011, when astrophysicist Mario Livio dug through the dusty archives of the Royal Astronomical Society, searching for the original 1931 correspondence. Livio's findings were astounding. Lemaitre had translated the paper into English himself, and he had intentionally deleted his own expansion calculations out of profound humility. Lemaitre stated that by 1931, Hubble had already published far more robust, empirically sound observational data. Lemaitre didn't care about priority or ego. He cared solely that the scientific truth was known. In 2018, the International Astronomical Union officially voted to right this historical wrong, renaming it the Hubble-Lemaitre Law. And yet, the ultimate, confounding irony of Hubble's entire scientific career remains. The media dubbed him the father of the expanding universe, but the sources clearly indicate that Hubble himself didn't even believe it. Despite providing the foundational observational evidence, he was aggressively skeptical of the theoretical conclusion. In all his subsequent writings, he was extraordinarily careful to refer to the redshifts as apparent velocities. He steadfastly refused to claim the galaxies were physically accelerating away. Instead, he favored a concept known as tired light, the idea that light waves simply lose energy and stretch out as they travel across vast billions of light years, creating an optical illusion of expansion. He maintained to his dying day that the universe might actually be completely static. Not until the empirical resources are exhausted need we pass on to the dreamy realms of speculation, Hubble famously stated. He was terrified of the monster he created. If the universe was expanding, running the clock backward meant it started from a single, infinitely dense point, a theory championed by Lemaitre and George Gamow that eventually became known as the Big Bang. Hubble provided the spark, but he fundamentally refused to stand near the fire. As his scientific legend grew, forcing the creation of the Big Bang Theory, his personal life descended into an entirely different kind of surrealism. We must examine the duality of his private existence, because the man mapping the cold, indifferent void of space was simultaneously immersing himself in the glittering, hyper-manufactured world of Hollywood. In 1924, precisely as he was discovering the staggering distance to Andromeda, Edwin Hubble married Grace Burke. Grace was a widow and the daughter of an exceptionally wealthy California banker. Her elite social standing and massive financial resources, combined with Hubble's skyrocketing international scientific fame and his polished, aristocratic Oxford persona, instantly elevated them to the status of royalty in Southern California high society. They weren't just attending boring faculty dinners. They were hobnobbing with the absolute cultural titans of the era. The historical sources show them routinely socializing with Charlie Chaplin, William Randolph Hearst, Igor Stravinsky, and Aldous Huxley. It was a fiercely glamorous life. In 1937, Hubble and Grace attended the Academy Awards alongside legendary director Frank Capra, and Hubble actually received a standing ovation from the biggest movie stars in the world. He was a pioneer of the public intellectual as a celebrity, navigating the superficial brilliance of Hollywood by utilizing the exact same intellectual armor he had forged at Oxford. He treated it all as a grand stage, but underneath this highly manicured, glamorous social life, there was a profound, quiet, private tragedy. He and Grace desperately wanted a family, but their only child was stillborn. That devastating loss had a massive impact on them. It forces us to question the psychological function of his lifestyle. Did the tragedy of losing a child push him further into the cold, calculated, predictable safety of the stars? Did it push him into the distracting, validating glamour of Hollywood? It feels as though the celebrities, the parties, the tweeds, and specifically his beloved pet, were an emotional buffer against the void, a way to control his immediate universe when he couldn't control life and death. Amidst all the high society networking and unfathomable cosmic calculations, the absolute center of Hubble's domestic universe was a giant, notoriously spoiled black cat named Nicholas Copernicus. Hubble absolutely adored this animal, to a degree that surprised everyone who knew his stern public persona, even jokingly referring to their grand Pasadena home as Nicholas's estate. Grace wrote extensively in her diaries about this dynamic. She described how Edwin would retreat to his massive study to execute incredibly complex, taxing mathematical calculations about the distance and velocity of galaxies, spreading his papers all over the desk. Then, Nicholas the cat would arrive. The giant feline would jump up and sprawl completely over the intricate math, blocking everything. And Hubble, this towering, stern, fake British major, the man who intimidated Albert Einstein, would refuse to move the cat. He would just look at his wife and gently say, "He's helping me." It reveals a softness and vulnerability strictly kept hidden from his professional rivals. A man seeking simple companionship amidst the crushing scale of his work. But this quiet domestic life was violently interrupted. When World War II broke out, Hubble, despite being in his 50s, felt an overwhelming call of duty. He abruptly left the pristine observatories of California and moved across the country to Maryland to work for the U.S. Army at the Aberdeen Proving Ground. The pivot is jarring. He went from mapping the macrocosm of galaxies millions of light years away to designing high-speed cameras to study the absolute microcosm of exterior ballistics, the precise flight paths of bombs and rockets. He spent years directing intense military research to increase the aerodynamic efficiency, firepower, and accuracy of U.S. military weapons. He and Grace lived in a drafty rental house on an island in Maryland that they jokingly referred to as the haunted house. His mathematical work was so vital to the war effort that he actually received the Legion of Merit in 1946. Whether mapping a galaxy or a missile, he applied the same relentless empirical rigor. After the Allied victory, he returned to California for his crowning post-war achievement, helping to design and oversee the construction of the brand-new 200-inch Hale telescope at Mount Palomar. It was a staggering engineering achievement, 4 times more powerful than the 100-inch Hooker telescope. In 1949, as a testament to his legacy, he was granted the honor of being the very first person to officially use it. Yet, despite his international fame, his military medals, and his cosmic discoveries, Hubble's final years were consumed by a deeply bureaucratic battle that he ultimately couldn't win. Throughout the latter half of his life, Hubble was deeply, increasingly frustrated by the rigid rules of the Nobel Prize Committee in Sweden. At that time, the committee relied on an antiquated definition of physics. Astronomy was strictly categorized as an observational science, entirely separate from physics. Therefore, astronomers were entirely ineligible for the Nobel Prize in Physics, no matter how profoundly their discoveries altered human understanding. Hubble viewed this exclusion as a massive insult to his field and his life's work. He spent his final years desperately campaigning for astronomy to be officially recognized as a legitimate branch of physics. He hired a publicity agent. He lobbied aggressively, calling in favors from prominent scientists worldwide to pressure the committee. But while he was fighting this administrative war, his body was failing. In 1949, while fly fishing in Colorado, trying to maintain that rugged athletic persona, he suffered a massive heart attack. He recovered just enough to return to a highly modified, restricted work schedule, but the permanent damage was done. The end came quietly. On September 28, 1953, Edwin Hubble was walking home from his office in Pasadena. He suffered a cerebral thrombosis, a sudden blood clot in his brain, and died shortly after at home. He was 63 years old, and here we arrive at the bitter, tragic irony of his timing. Shortly after his death, the immense pressure he had exerted finally broke the ban. The Nobel Committee yielded. They officially changed their rules to allow astronomers to be considered for the physics prize. Furthermore, colleagues on the inside later confirmed that the committee was unanimously planning to award the next Nobel Prize in Physics to Edwin Hubble, but the rules dictate that the prize cannot be awarded posthumously. He missed the ultimate immortal validation of his life's work by a matter of mere months. But the final mystery of Edwin Hubble isn't a missing paragraph in a Belgian journal or a denied Nobel Prize. It is what happened immediately after he died, because it defies all logic for a man of his public stature. His wife, Grace, held absolutely no funeral. There was no public memorial service, no grand gathering of scientists and Hollywood elites. She had his body cremated quickly, and then she took his ashes and buried them in complete, impenetrable secrecy. She never told a single soul, not his surviving family, not his closest astronomical colleagues, and she fiercely protected that secret until she took it to her own grave almost 30 years later. To this day, despite numerous historical inquiries, absolutely no one knows where Edwin Hubble's remains are located. If you visit Pasadena, there is a small historical marker placed in front of his old home, but there is no grave, no headstone, no physical resting place to visit. It was a highly theatrical, meticulously executed exit for a man who lived a highly theatrical life. I want you to leave with this incredible poetic paradox. Just sit with this thought for a moment. The man who gave us the exact mathematical coordinates to map billions of galaxies across the infinite cosmos, the man who defined the physical boundaries of reality, ensured that he himself would have absolutely no coordinates on Earth. He completely intentionally vanished into the very universe he discovered. If you are fascinated by the hidden tragedies, the brilliant minds, and the untold mysteries of history's greatest figures, you need to subscribe to Legendary Lives Unveiled. Like this video, share it with someone who loves a deeply complex mystery, and let us know in the comments. Do you think Hubble's secret burial was his final act of theatricality? Was it the ultimate calculated vanishing act to secure his own mythos forever? We will see you in the next exploration.